Unit 2 exam review, question number 20. Simplify the following expression. We have the quantity 4x cubed y all being raised to the fourth power divided by the quantity 4xy squared all being raised to the third power. I could write this out, or I could use the rules. So the first thing I'm going to do is actually write it out. That will show you that it doesn't matter either way. So this top one says that whole thing is being raised to the fourth. That means I have it multiplied 4 times, and I have actually let's do insert equation, just because then it gives me the exponent and that looks nice. 4x being raised to the third. I'm going to press the space bar and it puts it up there for me so it looks nice. Y, and raise this to the fourth, space bar up there, divided by, again, I'm going to do quantity 4xy squared, and I'm going to do the space bar to put up in the exponent just so it looks nice, and raise that all to the third, press the space bar so it raises it to the exponent, and press the space bar once again so that it looks like it did in the book. So over here I could write this as, I'm going to copy this and press equals 1, 2, 3, 4. So this fourth power says that I am multiplying, I just want to get rid of that guy. Sorry, let's not highlight the 4, we'll highlight just this part. Equals 1, 2, 3, 4. There we go, that's better. So that's saying that I have all of that being multiplied 4 times. So that means I have 4 times 4 times 4 times 4, or 4 to the fourth. It also means I have x to the third 4 times. So how many x's is that? 3, 3, 3, and 3. That's x to the 12th. And the last one I have y to the fourth, because there's 4 y's. So I could do it this way, which is the longhand, or I can do the rule, which is if I have an exponent to an exponent, I multiply the exponents. So here I don't have anything with the fourth, which means there's just one of them. So I can think of a 1 being here in the exponent. So I multiplied this 4 out here to the exponent in here, which gives me 4 being raised to the 4 times 1, which is 4. And I'm going to do a space bar so it looks nice. The next one, again, I'm going to be multiplying the exponents. So 3 times 4 gives me x to the 12th. And the last one, y being raised to the fourth, because there's not an exponent here, so I assume it's a 1, because there's a y here, so I know there's one y. So y being raised to the 4 times 1 is 4. Same thing on the bottom. That gives me 4 to the third power, x to the third power as well, and then y here I have squared, so I need to multiply 2 times, or the 3 times the 2, which is 6. Okay, now I need to continue simplifying because some of these will cancel out, because x divided by x is 1. So that's one way of thinking about it, or you can just think of them being canceled out. There's several ways you can do that. You can list them out like we did, which would be here. Let's just work with just the x's for a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that's 12. Let's double check. 1, 2, 3. Yep, 12. And then on the bottom I have 3 x's, 1, 2, 3, and 3 of those, x divided by x is 1, x divided by x is 1, and x divided by x is 1. So one way of thinking about it is that I am canceling out 3 of those x's like such, which leaves me with 9 x's. So I could do that the long way, or I can subtract. If I have 12 x's on the top, 3 x's on the bottom, 3 of those x's will cancel, which leaves me with, here we go, equals, give us another fraction bar, sorry, my computer's being a little slow, which leaves me with x to the 9th on the top because 3 of them will cancel. Using that same process, y to the 4th here divided by y to the 6th cancels out all 4 y's here, and 2 y's on the bottom are still remaining. So this is y to the 2nd. Then the last thing, I have four 4s and 3 4s. So 3 of them will cancel, and I have 1 left on the top, which is a 4. Now I could leave it like this. This is beautiful and perfect. It is correct, but I can see that of the answers, they want to have everything up on the top. So one way I like to think of this is these variables, the exponents, they can go on the top or the bottom. It doesn't matter. They are multifaceted. The only thing is, what I like to do is kind of give an analogy. These guys have, let's say it's a 2-story apartment building, and they have a ticket to go to a party, but they have to go to the specific floor for the party. If they have a positive ticket, they are on the correct floor. Keep them there. So this down here, this guy, if I want to bring him up because he is positive down here, that means that he's on the wrong, or he's on the right floor. And if I want to bring him up, he becomes on the wrong floor. So it is 4x to the 9th. They're on the right floor. Everything's good. If I want to bring that y up though, it makes him in the wrong floor, so it makes it y to the -2. Another way of thinking about it is if I'm going to be subtracting this 4, like we did 12 minus 3 gave me y to the 9th, I could do 4 minus 6, bring it up here, minus 6 gives me -2. So I have two different ways of doing, lots of different ways of manipulating that one. Let's go see if any of them match. So I do have 4 here, here, and here. The 16 is wrong, so I'm not going to go any further on those. X to the 9th, I have here and here. So then it's just the last one, y or y to the -2, which we just went through, so it'll be this one here.